All right, this is the continuation of linear programming problems. The example on this page says we want you to graph y is less than or equal to 3x plus 2. So on this screen shows the steps with the graphing calculator that you can graph that inequality. So look at number 1, you press the y equals button. Number 2, you're going to choose number 3, xt theta n. So 3 represents the number 3 in the equation. Xt theta n represents the variable x, addition symbol, and then plus 2. So that's going to go ahead and type into the graphing calculator as an equation. On step 3, you need to choose the left arrow key 6 times to get to the left of y sub 1 so that it's flashing. So it's flashing, and then what you have to do is you're going to enter and then choose the arrow key down to select the line area. After that, press number 5, press to the right repeatedly until the triangle pointing to the lower part is displayed. So you kind of see that on my screen below here. After that, you go and push the down arrow, enter. And what will happen is this will change the graph from a line to a shaded below the function. So this is what the viewing screen will look like. So here's your equation typed in, and you're choosing the line where you're shading below. And then this is what it should look like when the inequality is shaded. Here's that y-intercept of over 0 up 2, and it has your slope, and it's shading everything below or less. To put inequalities on a TI-84 plus CE, you would go to the y equals editor, input the equation, then use the left arrow key to access the inequality symbols located above the less than, greater than, less than or equal to, greater than or equal to, and then select one of the appropriate inequalities. Then you would graph that in the shaded region. All right, here's an example of linear programming. So when we get to the graphing of the constraints, go ahead and try and graph the entire system with the graphing calculator. I also will be showing how to use the graphing calculator in class. All right, example. Baking a tray of corn muffins takes 4 cups of milk and 6 cups of wheat. A tray of Bran muffins takes 2 cups of milk and 3 cups of wheat flour. A baker has 16 cups of milk and 15 cups of wheat flour. So I'm going to go ahead and stop there and identify my variables. So my x is going to represent the number of corn muffins. And we'll let y equal the number of Bran muffins. So this will be my x and my y. So this will be corn and Bran. Then we have some restrictions. We have milk and wheat. And then their maximums allowed. So tray of Bran muffins is 2 cups milk, a tray of corn muffins is 4 cups milk. 3 cups for wheat for corn, 3 cups of wheat for bran. Then we have their restrictions or maximums. So there are 16 cups of milk is the maximum, and 15 cups of wheat is the maximum. Then we have the profit that'll happen. So I'll put the P there. So it's $3 for every tray of corn muffins and $2 for every tray of bran muffins. So $3 and $2. So what I have in the blue is going to help us write the profit equation. So profit equals 3x plus 2y. Then we have our constraints. We cannot have a negative amount of corn muffins or a negative amount of bran muffins. So that's going to make our graph in the first quadrant. Then we have the constraints on the milk. 4x plus 2y less than or equal to 16. So that's your milk. Then we have the wheat restriction. 3x plus 3y less than or equal to 15. Now we're going to go ahead and graph those inequalities. If you want to stop and type those into the graphing calculator, when you type them into the graphing calculator, you need to make sure that they are in slope intercept form. Y equals mx plus b. Now we've spent some time in previous examples to find the intercepts. So our equation for the milk, the x-intercept will be 4, 0. The y-intercept will be 0, 8. For the wheat, the x-intercept will be 5, 0. Y-intercept 0, 5. All right, remember the x-axis is the number of corn trays, and the y-axis represents the number of bran trays. Pretty small numbers, so this will be 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8. Then we'll graph the purple line first. Ordered pair 4, 0 and 0, 8. Straight line. And then we'll shade below, less than. Next one, 5, 0, 0, 5. And then we shade less than. And the overlap which will be the feasible region, is right in the red. And then we identify our vertices. So the first vertex right here is 4, 0. And I know this you can't tell from my iPad here. This is 3, 2. Up on the y-axis, 0, 5. And then 0, 0. So those are our 4 vertices. Then we're going to go ahead and find out what is the maximum profit. So we're going to substitute those 4 vertices into our profit equation. So here's our profit equation. So 0, 0 is going to produce 0 profit. 4, 0 will produce $12 in profit. 0, 5 will produce $10 in profit. 3, 2 will produce $13 in profit. So the last one is the maximum. So the profit maximum will be $13 when you make 3 trays corn muffins and 2 trays Bran muffins.